Good day, everyone. You are welcome to another session of Computer Programming 1 using Java. In our previous class, we have learned the decision making and loops in Java, looking at the if statement, if else statement, if else ladder statement, switch, and then switch statement. We also look at the for loop, while loop, and then do while loop, considering their syntax in Java programming. Today we are going to introduce you to object-oriented programming in Java. Just an introduction. We are going to have an overview because in Java programming too, we are going to do object-oriented programming in depth. So in our class today, we are going to explain the fundamental concept of object-oriented programming. We are also going to implement some of the object-oriented principles in Java code. Therefore, understanding the core principles of Java. We are also going to utilize the built-in method, times, and string effectively. Thus, you are going to also choose appropriate data structure and collection for what? For different scenario. So that at the end of this class, our viewers out there can be able to design and implement a well-structured, reusable, and then so that our viewers around the globe can be able to create, design, and implement a well-structured, reusable, and maintainable Java code, can be able to solve in an object-oriented manner, as well as can be able to understand the relationship between objects and their attributes, and then the behavior. So, introduction now. We know object-oriented programming, or OOP, is a very powerful programming paradigm that resolves around objects. So everything in this, it's now resolved around what we call object, right? It resolves around what we call object. So everything. So our instances, our classes, our inheritances, our behaviors are all around this object. This object, we have dealt with it in our previous classes. We know. Then the fundamental idea behind this OOP is to model a real-world entities and their interactions in the software. So these entities, we said we have tangible and intangible entities, which are what? Which are objects. So they said the real idea behind this OOP is to what? To model these real-world entities, that's the tangible entities, and then their interaction within the software. How are they interacting within software? This is what OOP is after. Are we together? So now we also have what we call principles relating to object-oriented programming. One, these principles are what? We have polymorphism, we have inheritance, we have capsulation, and we have abstraction. Let's do it this way. We have polymorphism, we have inheritance, encapsulation, and abstraction. So these are the what? Four basic principles of object-oriented programming we are having. One, when we talk about polymorphism, this performs a single actions in a different way. A single action is this means can perform a single what action and in many ways. That's what it means. That's polymorphism. So it means you can create a code, one single code, and then you reuse it in many ways. That's what if we start implementing our object-oriented programming, that's what we are going to do. We are going to write a single code, and then reuse it in a multiple way. So looking at the inheritance now, inheritance it means this is simply done as a compile time, or it's a what? It's a compile time polymorphism and runtime polymorphism, because polymorphism is being what? Divided into two, the runtime and then the compile time. So this inheritance is done, is it carried out or is executed at that phase. But also this inheritance allows you to inherit a code of another of another executable code, or a code within a code. So you can inherit the features of a certain code in what? In inheritance. That's what it does. So we also have encapsulation, where you can write a very complex program, then you now encapsulate one important program within it, without what? Without people get to know what is inside, just like your what? Your normal usual capsule there. So you can encapsulate information within a code, one important information within a code, and get to use them in Java programming. Then abstractions, we also have abstractions where you can be able. Then the last one here is the abstraction. We said abstractions is refers to the hiding of a what? Of the implementation details of a code, and then exposing only the necessary information so to the user. So for instance now, if we may have a bank account, we may have a bank account which might be extended to what? To a various account of savings, that's account types now, or just we said account types, right? Bank account types extended to what? To this we said extended to bank account. So in this you can be able to hide what? To hide the code implementation details of a what? Of a code, and then expose only the necessary ones to the user for him to be able to work with. So when we come to what? To real implementation of our OOP, we'll get to know all these abstractions, polymorphism, inheritance, and then what have you. So we talked about polymorphism earlier. This polymorphism has also its importance, its advantages and benefits. So what are the advantages of this? So most of these advantages of the benefits are worked interchangeably amongst these three key components of what? Of three principles of object-oriented programming. One, we said code reusability. So polymorphism promotes code reusability, but by allowing methods with the same name to be what? To be used for different purpose, or for different object to be what? To be utilized. We also have the flexibility and what? Extensibility. So you can extend your what? Your code that is the what? Designed for a particular purpose. You can extend it now to what? To another code that you want to use it. That is why you said you can what? In a polymorphism you can do, we work with one code in many ways. So there is also that of clarity in what? Readability. Polymorphism always or often give you more readable code in a way that everyone that is going to use the system will be able to understand. That is programmers only. So it can also reduce what? Reduce coupling. So there is no need for you to be what? Coupling. You're bringing this one, bringing that. The only thing you are going to do is just inherit those things, work with them, extend them. That's all. So when we look at the inheritance, we said the inheritance is also part of the fundamental concept of object-oriented programming that allows users or allows developers to create a new classes in order to inherit the behavior from what? From an existing classes that's already been created. Assuming we have been working with a class called if example, so we can create another class called maybe new if example, so that we can inherit the features of the existing code into this very new particular code. So this what? Our inheritance means. So we also have the purposes of why do we need this inheritance. We said earlier, these benefits or purposes of importance, they work interchangeably. The same thing here, there is called usability. The only thing there is what we call method overriding. A method overriding here is meant by what? Runtime polymorphism. So we can also use what we call virtual keywords. So you can create keywords virtually in order to work with them. So we have what we call these types. These inheritance have their own categories or their own types. One, we have what we call single polymorphism. Types of inheritance, we have single inheritance, please, not polymorphism. We have single inheritance, we have multiple inheritance, we have multi-level, multiple inheritance, we have multi-level inheritance, and we have hierarchical inheritance also. So these are the three types of inheritance that we are having. In the first one, that's a single single inheritance. A class can be inherited, or a class can inherit from only one subclass. So it cannot inherit more than one subclass, right? So it can only inherit one subclass. So in what? In multiple inheritance, a class can inherit from more than one superclass. So you have many superclasses, so you can be able to inherit from each of these codes. So Java does not support multiple inheritance with classes also. So, but it can be achieved through what we call interfaces. So we are going to create interfaces. All these things we have been discussing. If we start the real implementation of OP, we are going to get it much more easier. Don't get confused, please. So we also have multi-level inheritance, where it can be what? Inherit from multiple classes, what? But in another class. It can inherit that in another class, and meaning that it can inherit to another class. That class will also inherit to another class. A class is just subclass upon subclass, subclass upon subclass. That's what it means by multi-level inheritance. In a hierarchical inheritance, multiple class inherit from that single subclass. Remember, that one will inherit from single what? Subclass. But this time around, multiple what? Multiple subclass are inheriting from what? Single superclass. Are we getting the difference between hierarchical and single? In a single inheritance, we said a class can only what? Inherit from one single superclass. One single superclass, not sub. Sub is the one that is down, super is the one that is up. So it's only can only inherit from one superclass. While in hierarchical, so multiple of these subclass, the ones that are under, multiple of them can inherit from what? Single superclass. That is the difference. So we have what we call arrays, and then we have what we call collections. Both of these arrays and collections are used in order to store and manage data in Java. So if it is about storing and managing data, arrays and what collections are the ones they use in Java for that particular purpose. So, but they differ in their what? In their features and then functionalities. That's both the what? Both the arrays and then collection, they are difference in their what? In their features and then their functionalities or implementation. When we talk about the array are lists of elements that you are going to declare like in an array form. Let's have, we said arrays are lists of elements that are declared, like say array equals to, you have to say, let me use another marker here. We use 1 2 1 2 3 4 5. So these are what? These are list of what? Of an array. So we said also in Java, our arrays are fixed in size, meaning the length of an array is established when it is created. Once this is created, so the length of this array is also established. Are we together? So if you look at this very well, the length of this array is the number of elements of a number of items in this element. So we have 1, 2 to 5. But here in array, we are starting the what? The counting from 0. 1, 2, 3, 4. So in a usual way, our array length is equals to number of elements within an array. Our array length or length of an array is equals to number of elements within the array minus 1. So how many in this? There are 5. 5 minus 1, we are going to left with 4. So the length of this element or this array is what? Is 4. Are we together? And this we said, this is determined as soon as the array is what? As soon as the array is declared. So also this one is determined. So also we can have this array can be integer. Maybe we can have syntax for that later when we are dealing with a proper OOP. So we also have Java collections. But in Java collections, these Java collections are what? Our framework comprises a set of what? Interfaces and classes. They are what? A framework that are set with a set of what? Interface and classes, offering the what? The standardized way of manipulating group of an element. That's what our collections are. They are the framework that you are going to what? Import into the what? The Java environment and work with them. So let's look at these common interfaces that we use for collections in Java. One, we have what we call list interfaces. List interfaces, we work with them in an ordered collection in an element where element can be what? Can be duplicated. Example, we have class, we have array list, we have linked list. Example, we said we have class. Pardon me, please. All my markers today. Class is equals to array list. Array list. Then we have linked list. So this is what we are having in the list interface. Also, we have set interface. So in set interface, this is an unordered array. Remember, we said in a list interface is unordered. It means you can be able to name them in ascending order. While in set interface is unordered. So it means the collections of a unique element. Example, we have classes like we have hash set, we have linked hash set, and we have tree sets. These are the 3 key examples of frameworks used for what? Or for collection in a set interface. 1 is hash set, 2 is linked hash set, 3 is what? Tree set. While in an ordered collection, that is in a list interface, we have array list and array or link list set. So the third one is the map interface. Map interface represents a collection of a key value point. Example of a classes of that hash map is what? Hash map, link hash map, and tree map. So these are the what? 3 good examples of our collections in Java, or our framework that is worked in Java. I still repeat, these are very, very important and paramount in these activities. 1 is the linked interface, 2 is the set interface, 3 is the what? Map interface. So this is what we have in this collections framework in Java. So the next one we are going to look at the example also later. So the next one we are having here is what? Is the built-in function. So the built-in functions here, what is those? Java provides us with a what? With a very rich set of built-in methods that can what? That are part of the standard libraries we work in Java. Are you together? These built-in functions, all you need for you just to call them, just the way we have been using our system.out.print. So the same thing we are going to use them here. So number one, we have what we call maths class built-in function, mathematics class or math class built-in functions. So all sort of libraries related to what? Hey, we have math class built-in functions. So here, all these sort of maths expressions are what are found here. Like to say the power, that's the square root. We know the square root of square root of 25. So in this, what you are going to do is what you have. Sorry, this is we have maths dot power is equals to 2, 3. It means it's going to raise this on top of this. Are you together? Then it will give you the result. So, but before you do this, you need to what? To what? Declare this. Let's assume I'm going to declare it like double maths or double whatsoever. I've declared it equals to this. So double maths, this is my variable, is going to store this into this particular this, that is for raised to the power. Are we together? So for the square root is what? Maths dot sqrt, maths dot sqrt. Then you write your 25 now. It will now do that. So you need to do the same declarations and initialization at the same time. So for what we have, maybe you want absolute value, you give negative value, but you need what we call absolute value. So you can do maths dot abs minus maybe 5. It will now return positive 5. Are we together? So we also have a double random values. So you can have math.random, you now specify the whatsoever you want here, so it will return random numbers within this. So we also have a string class method. In a string class method, we have string value or string set. In a string class value, that's number 2, right? Under built-in function, we have string class value. In a string class value, you can have your string like this equals to hello world whatsoever. You can declare to whatsoever also. We have car, maybe m. This will return hello world, this will return m. And we have also, if you want to specify the length in this, you have text dot length, then you specify whatsoever here, it will return the number of items that are here. So you also need to identify, you also need to declare, and then you initialize this. So you have also string uppercase, that if you want to change anything from what? Small letters to uppercase to capital letters, you can do it text to uppercase. After you've declared everything, you can say text to upper. The U is capital letters, uppercase, uppercase. So you write whatsoever you want to write here in small letters, it will change it. Or you have text to lowercase, you write whatsoever, it will now change them to what? To small letters, or while printing it will now change them to small letters. So that's the second one. So we also have array class method. In array class method is, we have discussed that of an array. So in array class method, you can have an array like this, then you have your list of elements within that particular array. So that's what it means. You can also have this array, can be string, can be integer, and what have you. So we have what we call character length. Character length is part of the example I give in the string, that you have them like char value inside single quote, and then we also have system class method. In the system class method, you can have a survey like that of an array and what have you. So the last thing we have in this session today is what? Your date and string. So handling date and times in Java is a very crucial aspect of many applications. We know that. So Java provides several classes in what we call java.time package. So whenever you are doing that, you need to import your java.time package for you to be able to work with that. And java.time package should be what? Local date. That's just the same thing. You import your scanner object here, you also import your Java. You said import java.time dot local dates. So pin, you can start working with that. So to create your local date object, you can use your local date or local date, like you declared your local date as current date is equals to local date now. You have your local date. This is the data type. So you give it a variable, local date, maybe date and time, date, time. This your variable is equals to local date now. You open and close your bracket. With this, you can have your local date displayed on the screen, and you can also have local time. You can declare to your local time and what have you. So this is what we have for you in today's sessions. I believe we have enjoyed these sessions. Please keep practicing so that once we start implementing this using our Java code, you can be able to do that. So you can go about seeing how you can install your Eclipse, go about setting your Java environment and what have you if you've not done it. So when we come to deal with that, we are going to do it in this class. Thank you for being with me. Remain blessed.